Hey guys, Miss Green here to talk about specific heat and a couple other elements of energy that we'll get into this week. So specific heat is a chart on a reference table on page 1, and it is heat energy measured in joules, which is a metric unit of energy. Pretty much what specific heat means is the amount of heat energy that is needed to raise the temperature 1 gram of that object 1 degree Celsius. Liquid water has the highest specific heat, coming in at 4.18 joules, while a rock or any type of dirt, or when you talk about land, you would talk about maybe basalt or granite. That's kind of a middle of the road specific heat at 0.84 joules. And then lead or copper is going to have the very least specific heat, lead with a specific heat of 0.13 joules. So when you think about, the first very, very hot days of summer, maybe school just let out, and you get into your car and by accident you touch the metal part of your seatbelt that was baking in the sun in that hot car, it almost burns you. The reason why it almost burns you is because anything that's made of metal, like iron, copper, or lead, have the lowest specific heat, meaning that they need a very little amount of energy in order to change temperature, and they will change temperature very quickly. But you expect to go to the beach on that very first hot day of summer and jump in the ocean and for it to be nice and warm. But if anyone has ever been to the beach at the end of June, it is not warm at all. The ocean is ice cold and stays ice cold, honestly, almost all the way through July into August. And that is because of the specific heat of liquid water. If you notice at the top, 4.18 joules of heat means that it takes water a very long time to gain enough energy in order to change temperature. So that's why also, because it's hard to change temperature, it's difficult for water to cool back down. So ocean water is usually going to be very warm in August and then through September and October when air and the land has also gotten very cold. We like to think of specific heat as like a stubbornness scale, right? The higher the rating, the more stubborn it is to change or resistant that it is to change. You could also think of it as like a time or a race. So if you came in 4 seconds and somebody else came in 0.13 seconds, obviously lead won the race in this case. So lead is the fastest to change temperature. Water, in this case, came in last place of the race and it was slowest to change temperature. The different specific heats of different materials, such as water and land, play a major role in its climate. Since water has a higher specific heat than land, it takes a longer time to heat up and cool off, which is why maritime regions, we know maritime means by the ocean or by a marine environment, have more moderate climates. Now, when we say moderate climates, we mean that they have cooler summers and warmer winters. So their temperature is in the middle. It's not too hot, not too cold, just right. It's kind of Goldilocks style. So we know, living on the coast and living on an island, that this is kind of the case. Maybe your summers feel pretty warm, but on average, Long Island usually gets to about 80-something degrees in the summer. Denver, Colorado, which is inland, a term that we'll be talking about as we get into climate, very far away from any ocean or coastal area, therefore has much higher temperature fluctuations. Summers in Denver can get to the very high 90s, almost 100 degrees, and winters in Denver will be much colder than our standard winters as well. There are a few other characteristics that determine how much electromagnetic energy can be absorbed in certain objects. Light versus dark, for instance. I feel like we've all had the situation where you go outside in the summer and maybe you didn't think ahead and you wore a black shirt. That, because dark absorbs light and energy, is going to actually make you much, much warmer than if you were wearing a light or, say, a white colored shirt. So dark things will absorb more electromagnetic energy and light things will do the opposite. They will reflect electromagnetic energy. However, texture plays a role as well. Things that are rough are generally going to absorb electromagnetic energy a little easier, while smooth things will reflect electromagnetic energy. So rough absorbs and dark objects absorb, but light-colored objects reflect, and then smooth objects also reflect. The better a material can absorb electromagnetic energy, the better it radiates. Now, I want to point out that radiating energy and reflecting energy are very different. If you think of a radiator, like an old school heater, it's going to be very, very hot to the touch because it already has all that energy. So anything that's going to be have absorbed a lot of energy is going to radiate that energy. You can think of this for like blacktop in the summer, because it's so dark and it is rough also, it's going to absorb a lot of electromagnetic energy. If you ever touch it in the middle of a summer day, it's also super hot to the touch because it absorbs so much energy, it also radiates that energy back out. Now, electromagnetic energy from a global standpoint is going to be a little more general. We see transformation of electromagnetic energy when short wavelengths are absorbed by the Earth from the sun and emitted back out from Earth into space as longer wavelengths. So we're going to see, let's make this blue. We know that, for instance, here's the sun. We'll give it some really short wavelengths coming towards the ground, and we're going to draw this together as well. And then we'll get some infrared, which is a longer wavelength, which is radiated back out from Earth back into the atmosphere. So again, infrared radiation is going to be radiated back out from Earth into space, while we know that the sun gives off UV and some of the shorter, more dangerous electromagnetic energies back towards Earth.